looking. I have no idea.
Okay.
Okay.
Like it's
Remind me, Tom. We'll look.
Joe was like table K.
Okay, guys. Veronica's gonna sketch this. So if you haven't tried it yet, try it. So you guys, now she is sketching it by hand. And you're going to use that sketch to find your absolute and local maximum and minimum values. Now when it says use graphs and transformations, that means use the fact that you know it's a parabola.
No, they just want
That
you
you
to
know
look at the
the one is a reflection, aka upside down. And then it's shifted up to.
Who else?
Who's on the table?
You guys only had 4 couples.
You, Alec.
I didn't see the 5th couple.
Me, Lauren,
Grr, mistletoe tables. Did you draw this function already?
Yes.
It's not. Grr.
Yeah. Okay, we have more.
Oh yeah, that is
More
neat. I
desserts.
forgot what
We'll
this
say
graph
there's
was.
people sitting there.
Yes, I don't really know.
Well, he's a defiant little quipian, isn't he?
What? What are you talking about?
Don't erase too much, it gets angry.
Don't judge
It's
me.
angry.
Yes, it does.
Wow.
Yeah, I thought it was great.
Okay, so she has the parabola here with a closed dot on this side and an open dot there. She has a upside down parabola shifted up to from here to here, both closed dots. Perfect. Yay. Okay. Now, I guess we can just label them this way. Where is your and I realize that as I'm asking these questions, you can tell me there is none. Okay? All right. Where is your absolute max?
Zero.
There is one.
Zero.
Yeah.
Because it exists.
Right. Absolute doesn't have to have anything like on both sides. Doesn't have to have stuff on both sides. Absolute min.
Oh, absolute max. No.
Very
None.
that's not.
Right.
For some reason, I thought you asked for the minimum first.
Did you? Okay. Right. So no absolute minimum. Local max and local min.
Same and absolute max.
No,
Never mind.
not
Never mind.
Right. So we can say no
Yeah.
local extrema. That's it. We're done. So all that graph had was an absolute max and a cool look. Okay.
Or maximum?
Are we still recording?
We are again. I shut it off when you guys took a break.
Just making sure. I didn't want you to go through the whole lesson and be like, oh.
Yeah, oh darn it. Recording at 3:27, yeah. Okay. All right, find the critical numbers of the function. I guess I should probably pause this here while Marissa finds her own derivative. Okay?
Oh, yeah.
Yes. Okay, so how do you guys find critical numbers once you have the derivative? Set
the critical numbers, so the bottom has to equal 0 too.
Correct. Right, because critical numbers are where your derivative equals 0, that's the top is 0, and where the derivative is undefined, which is where the bottom equals 0. Okay? I mean, you might not get something for one or the other of those, but you want to try. Yes, Preston.
Were we supposed to find that?
No.
Okay.
They just found F prime. Really?
It's not a shirt.
Oh, no, that was the pen probably went funny on his F. Yeah, that did look like a double prime. Yeah.
Sorry about it.
It's on his shirt.
It's on his shirt.
I did realize, it would be nice to have one of those projectors that doesn't put math all over your face, because I did realize that in the videos.
Yeah.
Not that it matters.
Okay, so
I think it's just 0 and -0.
Exactly. Oh, good. Wait, leave that there. Okay, good. No, go ahead. You can keep doing that. I was just going to say. Wait, let me. So over here too, Marissa, right? He started using the quadratic formula. There you go.
What?
He was using the quadratic formula for the denominator to show that actually didn't have any real roots.
oh shoot, I didn't factor this out.
So that's in terms of all that crap.
I just like got rid of it. So
Oh, okay. So that gives you one of the solutions.
I forgot how to do math.
It happens.
And then I missed
Okay.
the bottom.
Yeah.
Oh god.
It doesn't equal those either.
Oh, square root of. Wait. It's gonna
Exactly. So that's when you go full, cross it all off.
be no real.
Yeah, no roots.
Okay, so
See,
this camera's really trippy because you're like on going in this side, but it's not mirrored. It's like it flips it,
Uh-huh.
so you're on the
So if you
opposite
put a-
side.
If you put a slash through it, does it make it not
Not real.
No real numbers.
Okay, we good?
Is that it?
Yes, it
So
is.
there are no critical numbers.
Well, there
Oh,
are.
except those two.
Yeah, right, those two.
Okay.
Okay, very nice. What else do we have? This is the best problem here. Find the absolute maximum and absolute minimum values of f on the given interval. All right. The reason why we just found critical numbers in the last one are because your maxes and mins possibly occur
I don't think that would.
at critical values, right?
Right.
Where else could they occur?
But it's a cosine function, so.
But it's only on an interval, so it might only have one or two because it's on that small. It might only have one.
The period is too high,
Uh-huh.
And that's
which is
So
negative pi to pi is.
too high.
Right.
The period,
I mean,
the period is not too high.
Yeah,
it's
but
probably
Yeah,
going to do one of
the interval
these.
is over.
It's probably
just
just
a
a
period.
The interval is too high.
Mhm.
So
Oh, okay.
But again, let's go back to this. The absolute max and absolute min are going to occur possibly at critical numbers, right? Where the derivative is 0 or possibly where the derivative is undefined if it ever is. Or it happens at endpoints. Think about the regular cosine function. I don't want to think about shifting it or putting an x in there or anything. I just want to think about the cosine function. So if your cosine function goes like this, right? Then here is an absolute max, here's an absolute min, here's an absolute max. Yeah, these two were at the endpoints. This one was at a critical number, right? So bottom line, what you need is you need to find the y values at your endpoints, and you need to find the y value at any critical numbers that you have. And you just need to identify the highest and the lowest.
okay.
Okay? So I'll pause and everybody can get started. Yes?
Is this the equation that does that kind of like on like a slanted line? Is it that
Yeah,
one?
yeah, yeah, right? Because you're adding x, and as x gets higher, you keep adding more to it. So yeah.
I know we've graphed it before, and I was like, does it does better than I think it's cool. So.
Yeah, it is. It's a neat graph. Okay, so what is everybody in here doing right now before I pause this?
Finding the values.
Derivative of that function.
Okay,
Find
good.
the critical numbers, and then we're gonna test them.
Yeah,
Nasty
okay.
high.